Question 3. The image below shows a transverse section of leaf from the Chinese privet plant, Ligustrum lucidum, which looks suspiciously like the privet Ligustrum that you looked down the microscope at. But they found a different one, hopefully to put you off. Name tissues A, B and C. Well, they're the same as you saw. So A, just learn your diagram. Palisade, mesophyll. B, well, you've got to remember which is the it's the vascular bundle, but which is which. They look like bigger empty cells, and then the other smaller cells in there. So what the big empty ones called? Well, they're the xylem. So xylem. And it's worth noting here that common answers include names of cells here when it's asked you for tissues. So the name of the tissue. And C, it's this single layer of cells on the bottom of the leaf. Very similar to the ones on the top. So these are the epidermis layers. But which one is it? It's the lower epidermis. So lower, and you needed to say lower. And so you get 2 marks if you can get all 3 of them right, and if you get 2 of them right you get 1 mark. Get 1 of them right, you can't have anything. Part B, explain why guard cells are important to the functioning of the plant. What do guard cells do? We can split this into, well, they open. Why have we got a hole there? Why have we got this stoma there? And then why do they close? So, you know, essentially, why do they open and why do they close? So they open to allow anything that's got a hole in it, has got a hole in it to allow something in or out. And what does the plant want? Well, it photosynthesizes, so it wants CO2. So they open to allow in CO2 for photosynthesis. That's why the plant's leaves have got holes in them. And then, okay, all well and good, but why do they want to close them then? Well, they want to close them so that they don't lose too much water. Particularly when they're not photosynthesizing, like at night. So they'll close them at night because there's no point having them open for photosynthesis, but they don't want to lose a lot of water. So they close to reduce water loss. So why do they open? Why do they close? Pretty straightforward question so far. It's mainly remembering stuff about the revision that you've done on leaves in gas exchange. Pretty straightforward. And again, it's 4 marks here. How do they open? So I need to go. I'm going to talk about them opening and not closing, and then tell that story that's in your notes. So let's just go through this. So they are. If we draw some down here, it's pretty rubbish drawing. So they are 2 cells, and this is the, if I highlight this cell wall, so you can see there the cell wall, it's not even all the way around, it's unevenly thickened. The hole in the middle, well, you can't see this because it's closed at the moment, but the hole will be there in the middle. And essentially, when you pump up these cells, increase the volume, because of the uneven thickening of the cell wall, that will cause them to change shape and open this hole in the middle of the stoma. So it's just how do we increase the volume of these cells, and that's, well, to start with we are going to pump something in, and that will attract water, and then that will increase the volume. So we just need to go through those steps. So what's moving in first? We're getting active transport of potassium ions. So K+ actively transported into the guard cells. And actually we only need 4 marks, and there's 6 steps in this, so even if you miss a couple of them out, you're going to be in business. There's another process that happens in here, which is starch gets turned into malate. Starch is a big molecule that's insoluble. Malate is a smaller, more soluble molecule, and so both these things together, so more ions that dissolve and more malate that dissolves, will change the water potential, which will lower that water potential. So let's mention that step. Starch converted to malate. This just looks like your notes. It's regurgitating your notes, which you should be able to do. This lowers the water potential. Remember, the highest water potential is 0, which is pure water. If you've got more ions or sugars or things like that dissolved, then that will lower the water potential. If you've got low water potential, what then will happen? Well, we'll then get water moving in by osmosis, because water moves across these membranes from a higher to a lower water potential. So water moves into the guard cells by osmosis. Water moves in by osmosis, and the guard cells then swell, become turgid, and they kind of curve apart, which is what we mentioned. So cells then swell or increase in volume, or worse that effect, become turgid and curve apart. And why do they do that? Because of this uneven thickening, which is just in your notes, and you've seen diagrams, due to uneven thickening of the cell wall. Or you might have mentioned the inner versus outer, like on this diagram. It's a pretty straightforward question. If you've learnt your notes, you can have 8 out of 8 for that one.